This is just a continuation of section 4.1. We covered lots and lots of section 4.1 in class, but today we're just going to finalize some details in regards to analyzing the graphs of polynomial functions and using our end behavior models. Oops, that's not the slide I want to show you. This one here, a summary of what we talked about in class, basically analyzing the graph using zeros. So I want to make sure that's perfectly clear. When you're looking at the graph of when you're looking at a function, let's say f of x equaling x squared multiplied by x minus 4, and we multiply that by x plus 1. So just a quick review of what we did in class. Step 1 was to determine the end behavior. If you wanted to follow this summary that you see in the book, determine the end behavior. An end behavior model would be g of x is equal to, we have a first power here and a first power here, and we add up all the powers and we get x to the fourth. So an end behavior model would be g of x equaling x to the fourth. Okay. Step 2 would be to find the intercepts. Okay, so the x-intercept would be, the x-intercepts would be x equals 0, 4, and negative 1 that you can see by just setting each of the factors equal to 0. Okay, and those are the x-intercepts, and the y-intercept, if we let x equal 0, would be f of 0 would equal 0 times anything, and that's just going to be 0. So we have an x-intercept of 0, but also we have a y-intercept of 0. Okay, so those are the x and y-intercepts. We also know that the x-intercepts are the same things as the zeros, so we have the same numbers. But we also want to find their multiplicity, and we see that the 0, the x-intercept of 0, has a multiplicity of 2, and the other ones, 4 and negative 1, both have a multiplicity of 1. So we have negative 1 and 4 also with multiplicities of 1, which means that those two, or the graph crosses the x-axis at both x equals 4 and x equals negative 1, and it touches the x-axis at x equals 0. Okay. Now, for step 4, determine the maximum number of turning points on the graph of the function. Since it's a fourth degree polynomial, the maximum number of turning points would be 3, always one less than the degree. The behavior of the graph near at each x-intercept, we already talked about that. The behavior would touch the graph, and so we don't even need to worry about that. We already talked about that. Use the information to draw the complete graph. Okay, so if we draw the complete graph of this function using all of this information, and this again is a review from what we did in class, we have an x-intercept of 0, 4, and negative 1. From the end behavior model, we know that the graph of this function opens up and shaped like y equals x to the fourth. But again, we have x-intercepts here. So we know it's going to come down, the graph of the function is going to come down through the negative 1 because it's crosses the x-axis at negative 1. And then at 0, we have a double root there, multiplicity 2, so it's going to come up and touch the graph, and then it's going to go back up through the x-intercept of 4. And that's how you graph this function. This kind of looks like a squiggly, but that actually comes straight down through the x-intercept of negative 1. So that would be the graph of that function. So that's just a quick recap. Okay? But now we're going to go ahead and graph or analyze the graphs of functions that we have to use our graphing calculator for. So get that graphing calculator out, and let's take a look at some graphs. Okay, just going to walk you through a whole slide here. Here we have the function. You should type this into your graphing calculator. I don't know if you can see that or not. X cubed minus 2.48 x squared minus 4.3155x. Did I say that right? Minus 4.3155x. Now I'm really concentrating on what I'm saying in my videos. I don't lose any more bets. Plus 2.484406. Okay. Well, step one, we're going to determine the end behavior, and the end behavior here would be f of x equaling x cubed. Let's let g of x be our end behavior model. Okay, it's degree 3. Step 2, graph the function using your graphing calculator. Okay, so we can see what we have here. If you were to graph this on your calculator, you can see that the x min and the x max are -5 and 3. We have a y min of -2 and a y max of 15, which would give you the perspective that you see here. Okay, and then if we approximate the zeros, we could see we have 1, 2, 3, 4, so almost all the way to -4, and then we see between now this is 15, this would be 5, 10, 15, so somewhere around 2.5 would be our y-intercept. Well, we could even just take a look here. We don't need to approximate our y-intercept. When you let x equal 0, all the terms go to 0 except for that term right there. All right, so then I'm going to go ahead and do this. Oh, I can't pause this video, can I? I wonder if I can. No, I can't pause it. So by finding second calculate, I should say, second calculate 0, we can see that we have a -3.79, okay, rounded to 2 decimal places. So -3.79 would be this 0 here, -3.79. And then we have another, a y-intercept here of, like I said before, this value up here. We can call the y-intercept 2.48. Let's just round to the nearest 3 digits on this one, or 2.484. And so that's all that we're looking at here so far, okay? And there are other things, though, that we can see. We're going to be able to find a maximum, a local max here, and a local min here. We'll be able to tell where the function is increasing, where it's decreasing, where we have local maxes and mins, and then turning points. So let's take a look at this next part here. We have same function. Table 7 shows, so step 4 is to use the graphing calculator to create a table to find points on the graph around each x-intercept. Now, I'm not necessarily interested in doing that, so not liking that right there. What I'm going to do here is, let's go to the next slide. And can I do this without having to stop the video? Alright, approximate the turning points on the graph. Yeah, we want to get to that. Don't worry about that step 4 where you're going to be using the table to find points around the x-intercepts. We're going to look at step 5, approximating the turning points. Okay, so we know that we can find the high points and the low points. This set of coordinates here, these are the coordinates for that maximum value there, rounded to 2 decimal places, and we see the coordinates here, 0.63, 1, which would be that turning point right there. Coordinates of that turning point. Okay, second calculate maximum here, second calculate minimum here, and we've done this before, so I'm not going to walk you through that again. Okay, that was the video for Monday, 2 videos ago, where I taught you how to do that. Okay, or I should say reminded you how to do that. Okay, so then let's take a look at this. So I'm running through this pretty quickly here, I know, but we've kind of gone through all this before, so but anyway, I'll show you on the calculator how to do a problem here. I'm going to have you guys do a couple of them and then check your answers on the calculator. So still, let's see, step 6, use the information in steps 1 through 5 to draw a complete graph of the function by hand, find the domain and the range of the function, and then also step 8 would be use the graph to determine where the function is increasing and where it is decreasing. Okay, and so we'll have a group challenge on during the next class where you have to completely analyze a graph just like you see here. And what have we done that's new? End behavior model, that's a new one. So here we have the entire graph. We've got end behavior. This would be your analysis here. You'd say decreasing on these intervals. You'd say on this interval. You'd say increasing from -infinity to -2.28. Okay, you would label the coordinates of each turning point. Okay, you also would say, and you don't have that here, but you'd also say that you have an absolute maximum value of 13.36. Did I say absolute maximum just now? I meant a local max of 13.36, okay? And you can say at x equals negative 2.28, at, okay, x equals that value. And then you could say you have a local min of 1 at x equals 0.63, okay? And so the 0.63 all the way to infinity is where this function f of x is increasing. And then again you have an end behavior model. That's really the only new stuff, end behavior model. And that's about it. Local max, you've got turning points, you've got the coordinates of the turning points listed here, you've got your y-intercept plotted here, you've got your x-intercept plotted, and you've got why is this point right here, negative 4, negative 4.57? Not sure why we need that point there. We don't. But this has everything. So this is a thorough analysis of a polynomial function that you get to use your calculator for. So there you go. Next video, I'm just going to have you guys do a couple problems, and then the video will show you how to completely analyze those. And if you've got that down, then you're good.